Good afternoon, students. Am I audible?
Yes, ma'am.
Okay. Okay. Uh, Tell me this, students, whether the PPTs are visible to you.
Yes, ma'am.
Okay. So today we are going to start with the unit number 3, geometric transformations. Okay. In the previous lecture, we have finished with our chapter number 2, which was raster scan graphics. In that, we have seen the line drawing, circle generation algorithms, and how to color the polygon. So these are the different algorithms for coloring the polygon that we have studied in chapter number 2. And now we are going to start with unit number 3 or chapter number 3, which is geometric transformations. So this chapter is having two subparts in it. First is, as you can see in the syllabus of this chapter, first subpart contains the two-dimensional transformations. So the different operations, transformations means what? The different operations that we can perform on given object. So if the object is two-dimensional, then we can have the transformations or different operations on that object, like translation of the object, rotation, reflection, scaling, and shearing. So these are the 5 transformations, two-dimensional transformations we will study. Then we are having the combined transformation. So combined transformation is nothing but at a time we can perform 2 or more operations on the same object. That is called as combined transformation. Then we are going to observe the rotation about arbitrary point and reflection through arbitrary line. So this is the part of two-dimensional transformations, and same thing we are going to carry out with 3D also. So 3D transformations, three-dimensional transformations, that we will take the example of a cube for simplicity, and we can perform the different operations on it: scaling, sharing, rotation, reflection, translation. Similarly, multiple transformation is nothing but the combined transformation part. So here we can have multiple operations on the same cube, on the same 3D object. So that is called as multiple transformation. And we will have the rotation about axis parallel to coordinate axis. So these are the syllabus points for the chapter number 3. Okay. Right. So let us see the definition of transformation first. So transformation are the operations applied to geometrical description of an object to change its position, orientation, or size. So we can perform the operation on the object in order to change. What we can change? The position of the object, that is the location. The orientation we can change, that is the angle, and size. So actual size also we can change. That means we can expand the object or we can compress the object. In both the ways, the size change is possible. So that all are called as geometric transformations. So the operations carried out on a two-dimensional object in order to change its place, that is position, in order to change its position, orientation, or size, is nothing but your geometric transformations. Okay. Okay. So that is about the geometric transformations, two-dimensional. Then we are observing the first transformation, which is called as translation. So what do you understand with translation? So translation is nothing but simply shifting of the object from its original position to a new position. Consider this diagram. So in this diagram, this box on which this CG is written, or this paper, you can see a two-dimensional entity. So it is a paper on which this CG is written. So it is placed with one vertices as the origin. Okay, this is the paper, and this is a two-dimensional paper where its one vertices, one of the vertex is lying on the origin. Okay, so this is your object. Now what translation does? Translation changes its position from original position to a new. So here we can perform the change in the location. So here you can observe this original object is simply shifted upwards and towards right. So it has been shifted to new location. So this is nothing but the displacement. So originally your vertex was at origin, and now it has been shifted here with this distance along x-axis and with this much distance along y-axis. So that is nothing but the displacement of the object to a new location is called as translation. So if I'm changing the position of the object, is there any change in the dimension or size of the object? if I am changing the position only, then whether there is any change in the original objects?
No, ma'am.
Yes, that is simply I am picking this object up and placing it in some other position or other location. So that is called as your translation. So whenever I am taking the translation on two-dimensional object, then you have only displacement, but the original dimensions of the object, whatever was there before translation, the same dimensions are there after translation. Only its location is going to change. Okay. So let us see the definition. Translation is a process of changing the position of the object in a straight line path. So this is very important, in a straight line path, that we are going to change the direction, but in a straight line path. So that is called as translation. We can translate a two-dimensional point by adding translation distance tx and ty. So this distance on x-axis, this is the distance by which your original object is shifting. So this is called as tx. It is nothing but the distance along x-axis, displacement along x-axis we can say. And this much distance, object is moving upwards, so it is moving along y direction, and that is called as ty, which is your translation along y-axis or displacement along y-axis. Okay, so the amount by which you are going to shift the object along x-axis is tx, and the amount by which you are going to shift the object along y-axis is your ty. So you have to displace the object by tx and ty respectively along x and y axis. Okay, then suppose the original position is x comma y. So I will consider a point. This point is again a two-dimensional entity, isn't it? So point is a two-dimensional entity. So this is your x and this is y value. So this coordinate of the point are x comma y. Coordinates of this particular point is x comma y. Now I want to change its position. I want to change the point to a new location. Let us suppose this is the new location of the point. Okay, so earlier the point was here and now I have changed the point to a new location. So there is displacement along x-axis and surely there is displacement along y-axis. So I can call the new coordinates of these points are x dash and y dash. Right? Original coordinates were x comma y. Now it has been changed to a new location where the new coordinates are x dash and y dash. So is there any relation between x dash and x? Similarly, y dash and y. So the answer is yes. There is a relation between the original coordinates and new coordinates, and that is nothing but the displacement factor. So displacement factor along x is your tx. So this is the tx distance by which your x is moving. And this is your ty. That is nothing but the displacement factor along y-axis. So this is called as ty. So now, as tx and ty are the displacement values with me, so I can write down the expression as. So I can write down x dash. So what will be the x dash? X dash is nothing but this x distance of this original point plus this extra distance. This is the extra distance which is your tx. So when I add x into this tx value, then I can get the x dash. So x dash formula is your original coordinate x plus tx, displacement factor along x-axis. Similarly, y dash. So y dash is nothing but the original value y plus this ty distance. So when I perform the addition of y and ty, then it will give me y dash. The point y coordinate is y dash. So these are the two expressions I am getting for translation. Okay, all of you are getting this?
Yes, ma'am.
Okay, boys side. Yes. Okay. Right. So shifting of the object from its original location to new location, and shifting factor along x-axis is called as tx, and the shift factor along y-axis is called as ty. So this much part we have seen. Now, all the operations on the two-dimensional object is carried out by making use of matrices. So if I want to write these expressions in terms of a matrix form, how I can proceed? Here onwards, all the transformations, maybe it is 2D transformation or 3D transformations, all of them we are going to represent with the help of matrix, and that too matrix multiplication. I'm going to represent all the operations with matrix multiplication. So how I should write the matrices, new matrices of point P dash. So this is your point P dash, let us assume. So this is your point P dash, and this is original point P. So what I want to do is, I want to represent this P dash in terms of matrix multiplication of P with some T matrix. So T is nothing but your translation matrix. What I want to do is P dash, I want to represent with original matrix P into T. So T, in short, we are going to call it as a transformation matrix. Here, the transformation that we are considering is a translation. आपण इथे कुठलं ट्रान्सफॉर्मेशन बघतोय? ट्रान्सलेशन नावाचं, in which only position is changing. So here T represents T translation, the T matrix for the translation. So when I want to perform this multiplication for the matrices, I can write in this way, that is, if I want to get x dash y dash, so I am representing P dash in terms of xy coordinates. So P dash can be represented as x dash y dash. Then P can be represented as x comma y, because x, y are the original coordinates with me. Now, what can be your T matrix, so that ultimately I am going to get the relation between these two as this. X dash आणि y dash चे एक्सप्रेशन मला असं मिळण्यासाठी इथे मला काय लिहावं लागेल, so that I will get this form. Okay. So if I want to get x and y as it is, x आणि y जर मला as it is हवा असेल, तर I have to write identity matrix for it. Right? Because I want x and y as it is. I don't want to scale x. मला x ला कशाने multiply नाही करायचं. So if this original x and y I want as it is, then it means I have to multiply them with the identity matrix. So I'm writing that matrix here. So xy, if I want to get it as it is, I will be writing here, identity matrix. So 1 0 0 1, that is your identity matrix. Now When I multiply these two, what is the result I am getting here? XY, when I am going to multiply XY with this identity matrix, I am going to get XY as it is. Now, extra thing is I have to add the TX and TY to it. So addition of TX and TY can be carried out if I insert new element here. That is called as TX, the distance along x-axis. TY is the distance along y-axis. And now the dimensions of this matrix will be 3 by 3. So in identity matrix, I have inserted TX and TY so as to add the TX and TY value in X and Y respectively. So for that, as I am changing the order of this matrix, I have to change the order here also, because the matrix multiplication is done if the columns are same as that of rows of the second column. So you have to take the columns equal to 3, because here the rows are, number of rows are 3. So you have to maintain that order. And for that purpose, I will take the last element, which is called as 1 only. So that now in this matrix P, I am having number of rows. What are the dimensions of this? 1 row by 3 columns. This is the order of the matrix. And here it is 3 by 3. So when I'm going to perform multiplication of 1 by 3 with 3 by 3, I will be getting the result of 1 by 3. That 1 by 3 result is here. That is your P dash. Multiplication नंतर तुम्हाला काय result मिळतं? P dash मिळतं. So P dash is having currently the dimension as 1 by 2. So I will increase here also one element so that the order of the matrix will be 1 by 3 now. Okay. So what I have done, addition perform करण्यापेक्षा I am going to use the T matrix in such a way that when I will multiply P with T, I will be getting these two results. मग बघा या दोन्हीची मल्टिप्लिकेशन केल्यानंतर तुम्हाला हेच एक्सप्रेशन्स मिळत आहेत का? So I will start multiplying. So check here. Multiplication केल्यानंतर तुम्हाला काय मिळतंय? X is getting multiplied with this. This is your P matrix. This is P. And this matrix is your T matrix. Right? So P dot T, असं जेव्हा मी करते तेव्हा मला मिळणारे result X multiplied by 1. So X as it is. Y multiplied by 0. So it is 0. And 1 multiplied by TX. So this is your first term, X plus 0 plus TX. Now calculate the second term. That is row into second column. So X into 0, 0. Y into 1, that is Y. And 1 into TY, that is TY. So I am getting this second element. And again, this row with third column, X into 0, 0, Y into 0, 0, 1 into 1 is 1. So I am going to get 0 plus 0 plus 1. मग आता बघा, फर्स्ट टर्म मिळाली आहे मला X plus 0 plus TX. म्हणजेच काय झालं? X plus TX. आणि that I am going to equate it to the X dash. Left hand side ला तुमच्या X dash आहे. X dash Y dash 1 is equal to first element, second element and third element. बघूयात आपण second element पण 0 plus Y plus TY. So ultimately Y plus TY. So Y plus TY is the value of Y dash, the second term in the matrix, and 1 आणि हे 1 as it is. So मी काय केलंय? this translation process I have converted into a matrix multiplication. ट्रान्सलेशन मध्ये काय होतं, इथे ऍडिशन होत होती, ती मी कन्व्हर्ट केली आहे मॅट्रिक्स मल्टिप्लिकेशन. का तर मला एक्झाम्पल सॉल्व्ह करताना मॅट्रिक्स मल्टिप्लिकेशन केल्यानंतर सेम रिझल्ट्स मिळणार आहेत, कारण इथून पुढचे सगळे ऑपरेशन्स जे आहेत आपण ते मॅट्रिक्स मल्टिप्लिकेशननीच रिझल्ट आपण कॅल्क्युलेट करणार आहोत. सो ट्रान्सलेशन ऑल्सो वी हॅव कन्व्हर्टेड इनटू अ मॅट्रिक्स मल्टिप्लिकेशन टू गेट द सेम रिझल्ट्स. We are not changing the definition of the translation. मल्टिप्लिकेशन केल्यानंतर मी x and y चेंज करत नाहीये. मी काय करतेय, x मध्ये ऍडच करतेय tx. इथे बघा, x मध्ये tx ऍडच होतंय आणि y मध्ये ty ऍडच होतंय. पण for all operations on two-dimensional objects, we will carry out the operations with matrix multiplication. So I have written this T matrix for it. Getting it?
Yes, ma'am.
Okay. Poet side, if you are not understanding right now, then ask it right now so that I can repeat this, because this is the base and based on which you are going to solve the problems also. So if you are not understanding anything, ask me. Okay. Which part you are not understanding? Roll number 13. You are telling me to repeat. So which part you are not understanding? Can you tell me? Matrix. Okay. So matrix multiplication part. Okay. आता ट्रान्सलेशनचे रिझल्ट काय आहेत? ट्रान्सलेशन म्हणजे काय, तर एका पोझिशन पासून दुसऱ्या पोझिशनला आपण ऑब्जेक्ट मूव्ह करतोय. मग तो ऑब्जेक्ट पॉइंट असेल किंवा एखादं 2D पेज असेल किंवा ट्रायंगल असेल. सो ऑल दीज आर द two-dimensional objects. So I am moving that to a new location. बरोबर? So moving is done by adding tx आणि ty amount to get the new location. आता xy हे कोऑर्डिनेट्स आहेत, त्याच्यामध्ये मी tx आणि ty रिस्पेक्टिव्हली ऍड केले x आणि y मध्ये, तर मला मिळणारे कोऑर्डिनेट्स आहेत x डॅश y डॅश. म्हणजे जुन्या ओरिजिनल कोऑर्डिनेट्स पासून नवीन कोऑर्डिनेट कसा मिळवणार आहे तुम्ही, तर हा ट्रान्सलेशन फॅक्टर अलॉंग x अँड ट्रान्सलेशन फॅक्टर अलॉंग y हे तुम्ही जेव्हा ऍड कराल त्याच्यामध्ये तुम्हाला x डॅश y डॅश मिळतील. ओके, इथपर्यंत कळालंय आता सगळ्यांना? ओके, सो आय एम अज्युमिंग दॅट इथपर्यंत काही प्रॉब्लेम नाहीये. मग आता जेव्हा ऍडिशन असेल तेव्हा आता इथून पुढचे जे ट्रान्सलेशन आपण इथून पुढचे जे ट्रान्सफॉर्मेशन 2D ऑब्जेक्टवर करणार आहोत ते सगळे मॅट्रिक्स मल्टिप्लिकेशननी आपण रिझल्ट गोळा करणार आहोत. पण इथे काय होतंय, इथे आपण ऍडिशन करतोय, x प्लस tx आणि y प्लस ty करतोय. मग युनिफॉर्मिटी सगळ्या ऑपरेशन मध्ये असावी म्हणून इथे काय केलेलं आहे की हे सगळं आपण एका मॅट्रिक्स फॉर्म मध्ये रिप्रेझेंट करणार आहोत. हे सगळं एका मॅट्रिक्स फॉर्म मध्ये रिप्रेझेंट करणार आहोत. मी तुम्हाला एक एक्झाम्पल सांगते, एक सेकंड. आय विल स्विच टू व्हाईट बोर्ड. ओके, व्हाईट बोर्ड इज विजिबल टू यू? Yes?
Yes, ma'am. Yes.
Okay, so consider, we will consider one example in which this is your line. Okay, this line is having name as AB and A is having the coordinates, let us say 5, 5,5, and B is having coordinate 10,5. Right, horizontal line आहे, त्याच्यामुळं तुमचा y कोऑर्डिनेट 5 राहणार आहे, A कोऑर्डिनेट आहे 5 आणि B कोऑर्डिनेट आहे 10. ओके, आणि इथे त्याचा y कोऑर्डिनेट दोन्हीचाही 5 आहे कारण हॉरिझॉन्टल लाईन आहे. ओके, सो नाउ आय वॉन्ट टू शिफ्ट दिस लाईन 5 units up and or I can say 10 units up and 10 units right. Okay. मला काय करायचंय, ही माझी ओरिजिनल लाईन आहे AB, that I want to shift 10 units towards right and 10 units up. बरोबर. क्वेश्चन कळाला सगळ्यांना. 10 युनिट्स राईट शिफ्ट करायची ही लाईन आणि 10 युनिट्स अप शिफ्ट करायची. ओके. सो what will be the final coordinates of this line? What will be the final coordinates of this line? तर काय करणार आहे मी आता, आपला व्हॅल्यू काय, 10 युनिट्स टू राईट. What it means? 10 युनिट्स राईट म्हणजे कोणती डिरेक्शन आहे?
Right.
Right, it is there, but it is positive x-axis. Along positive
Yes.
x-axis, you are going to shift that point. And upwards म्हणजे कोणती डिरेक्शन आहे?
Y.
Yes, along positive y and that to positive. जर मी डाऊनवर्ड्स म्हटलं असतं तर तो निगेटिव्ह y च्या डिरेक्शनने असला असता. अपवर्ड्स म्हणजे वरती शिफ्ट करायचं म्हणजे तो पॉझिटिव्ह होणार आहे क्वांटिटी. तसंच राईट साइडला म्हणजे पॉझिटिव्ह एक्स आहे. जर मी म्हटलं लेफ्ट साइडला 10 युनिट्स, then that will be your negative 10. Okay, so we will consider that example also. मग आता बघा तुम्ही 10 युनिट्स राईट and 10 युनिट्स अप आहे. So I am going to add the values in this A and B. So what will be my A dash? हे x आहे म्हणजेच काय, ही व्हॅल्यू आहे tx ची तुमची, आणि हे y म्हणजेच काय, ही व्हॅल्यू आहे ty. This is your tx and this is your ty. बरोबर. द फॅक्टर बाय विच यू आर गोइंग टू शिफ्ट अलॉंग एक्स ऍक्सिस. कितीनी एक्स शिफ्ट करायचंय, 10 युनिट्स राईटला शिफ्ट करायचंय. सो दॅट इज युअर डिस्प्लेसमेंट अलॉंग एक्स. आणि 10 युनिट्स अप शिफ्ट करायचे, दॅट मीन्स इट इज युअर डिस्प्लेसमेंट अलॉंग वाय ऍक्सिस. सो आय एम हॅव्हिंग tx and ty विथ मी नाव. सो व्हॉट इज माय फॉर्म्युला? जर मला A डॅश पॉइंट्स मिळवायचे असतील तर ह्या एक्स मध्ये मला tx ऍड करावा लागेल आणि y मध्ये ty ऍड करावा लागेल. तसंच B हा नवीन पॉइंट मिळवायचा असेल तर काय करावं लागेल, मला ह्या एक्स मध्ये tx ऍड करावा लागेल आणि y मध्ये ty ऍड करावा लागेल. सो 5 + 10 म्हणजे मला मिळाला 15 हा पॉइंट, आणि या y मध्ये मी ty ऍड करतेय. सो दिस y प्लस ty value is 10. So I am having again 15. 15,15 हा पहिला पॉइंट आला A डॅश आफ्टर ट्रान्सलेशन. म्हणजे तो शिफ्ट झाल्यानंतर पॉइंट आला 15,15. नेक्स्ट B डॅश पॉइंट कसा मिळणार आहे मला? B डॅशच्या कोऑर्डिनेट्स मध्ये पण मला tx आणि ty हे डिस्टन्स ऍड करावे लागतील. ट्रान्सलेशन अलॉंग x ऍक्सिस फॉर पॉइंट B, ट्रान्सलेशन अलॉंग y ऍक्सिस फॉर पॉइंट B. So 10 + 10, this 10 plus tx distance. 10 + 10 is 20. And 5 + 10 along y-axis. So 5 + 10, I am going to get the value as 15. Okay. So let us plot the resultant line. 15, 15. So I will be drawing. This is your 10, this is your 15. Similarly, 5, 10 and 15, 20. Okay. Now 15, 15. Ha point kuthhe ala? I am going to plot it. It's somewhere over here. This is your A dash point now. And the next point is 20, 15. So this is your 20 point on x-axis and 15 same on y-axis. So I'm going to have there B dash. So if you observe, the dimension of the line has not changed. Earlier line chi length kiti hote? Line chi length hote 5. So here also I'm getting the length of the line is 5. I'm not changing any dimension of the line, but I'm changing only position. जी लाईन आधी 5,5 पासून 10,5 पर्यंत होती ती मी वरती शिफ्ट केली आहे अँड राईट हँड साइडला, अँड दॅट इज गिव्हिंग मी द न्यू लाईन A डॅश B डॅश. ओके, मग इथे मी काय करतेय, आय एम कॅरिंग आउट ऍडिशन, बट ऑल फर्दर ऑपरेशन्स, जर मी 2D रोटेशन बघितलं, 2D रिफ्लेक्शन बघितलं, 2D स्केलिंग बघितलं, तर ऑल ऑफ देम दे आर युझिंग मॅट्रिक्स मल्टिप्लिकेशन कन्सेप्ट. पण आता आपण इथं काय करतोय, आपण ऍडिशन करतोय. मग ते ऍडिशन नकोय मला मल्टिप्लिकेशनच हवं असेल या प्रोसेससाठी सुद्धा, तर मी काय करणार आहे, तर आय एम गोइंग टू राईट इट इन द फॉर्म ऑफ मॅट्रिक्स मल्टिप्लिकेशन. तर ते ऍडिशन मी असं कन्वर्ट करणार आहे जेणेकरून मल्टिप्लिकेशन केल्यावर पण मला हाच सेम रिझल्ट मिळेल. सो आय एम गोइंग टू कन्वर्ट इट इन सच अ वे दॅट आफ्टर परफॉर्मिंग मल्टिप्लिकेशन ऑल्सो आय एम गेटिंग दी सेम रिझल्ट्स. सो that I am writing as P dash dot P. मी मल्टिप्लिकेशन कॅरी आउट करणार आहे आणि त्यांनी मला रिझल्ट मिळणार आहे P डॅश. मग आता P डॅश म्हणजे काय तुमचं, ही लाईन, नवीन लाईन, रिझल्टंट लाईन. ओके, सो आय विल से दॅट for one point or for both the points rather we can say that. So this is your xy. So I am going to write it in this format, x1 y1 dash 1 and x2 y2 1. हे काय आहेत आता, x1 dash y1 dash 1 हे झाले A dash चे कोऑर्डिनेट्स. रिझल्ट नंतर हा तुमचा A चेंज होतोय A dash मध्ये, सो हे झाले A dash चे कोऑर्डिनेट्स. आणि x2 dash y2 dash 1 हे झाले तुमचे B dash चे कोऑर्डिनेट्स. ओके, देन मग मी फॉर्म्युलामध्ये काय टाकणार आहे, सेम हे झाले ओरिजिनल कोऑर्डिनेट्स x1 y1 1. These are the coordinates of A only. A चे कोऑर्डिनेट्स आहेत बिफोर ट्रान्सलेशन. म्हणजे ओरिजिनल P वरती जेव्हा तुम्ही एक ट्रान्सलेशन T अप्लाय करताय तेव्हा तुम्हाला ट्रान्सलेशनचं रिझल्टंट P डॅश हे मिळतंय. सो P इज युअर ओरिजिनल AB लाईन आणि T हे ऑपरेशन आहे त्याच्यावर. ओके, सो x1 y1 1 हा झाला तुमचा A कोऑर्डिनेट. सिमिलरली x2 y2 आणि 1 हा झाला तुमचा पॉइंट B. इथपर्यंत कळलंय सगळ्यांना?
Yes, ma'am.
पॉइंट साइड रोल नंबर 13. Yes, roll number 13. Okay, so I believe you are getting now. Okay, so हे झालं तुमचं P dash, हा झाला तुमचा ओरिजिनल मॅट्रिक्स P, and now you are going to multiply it with T. So T मला असा लिहावा लागेल की जेणेकरून मला मिळणारा रिझल्ट आहे तो x1 प्लस tx असं येईल. मग त्यासाठी काय होतंय, x1 ला जर मी इथं 2 वगैरे कशाने मल्टिप्लाय केलं तर मला मिळेल 2 into x1. पण मला तसं हवंय का, x1 ला मला काहीच चेंज करायचं नाहीये. मग कशाशी मल्टिप्लाय केलं तर मला काहीच चेंज नाही मिळणार. आय वॉन्ट टू मल्टिप्लाय इट विथ 1. जेव्हा 1 शीच मल्टिप्लिकेशन होईल तेव्हा ओरिजिनल तुमचं व्हॅल्यू x1च राहील, बरोबर. सो x1 I'm going to multiply it with 1. Then in the first term I don't want any other thing than tx. So tx मिळण्यासाठी काय करावं लागेल मला, इथे 1 आहे. 1 ला जेव्हा मी tx नी मल्टिप्लाय करते तेव्हा मला मिळणारा रिझल्ट असतो tx. आणि y ची टर्म हवी आहे का तुम्हाला, तुम्हाला रिझल्ट हवाय x डॅश. इथे बघूया, x डॅश हा रिझल्ट कसा हवाय, x प्लस tx एवढंच हवाय. त्याच्यामध्ये y ची टर्म नकोय. सो आय एम ऍडिंग 0 हिअर. म्हणजे काय होईल, y1 इंटू 0 झालं तर y कॅन्सल होऊन जाईल. मग तिथे राहील फक्त x ची टर्म आणि tx ची टर्म. ओके, तसंच आता मला रिझल्ट काय हवाय, y डॅश इज इक्वल टू y प्लस टी वाय हवाय. दुसरा रिझल्ट मला असा हवाय, y डॅश इज इक्वल टू y प्लस टी वाय. सो x ची टर्म हवी आहे का त्याच्यामध्ये, नकोय. सो आय विल राईट हिअर 0. y ची टर्म हवी आहे पण त्याच्यामध्ये काहीच चेंजेस नकोय, जशी आहे तशीच हवी आहे. सो आय विल मल्टिप्लाय इट विथ 1 अँड देन आय हॅव टू ऍड टी वाय. मग जेव्हा 1 शी मी टी वाय नी मल्टिप्लाय करेल तेव्हा मला टी वाय मिळेल and that will get added into this y. Okay, and to get 1 1 at the end I should write 0 0 1 values, so that ultimately x will get cancelled, y will get cancelled, and 1 into 1 after multiplication I will be getting the result as 1 only. आता कळलंय सगळ्यांना हा टी मॅट्रिक्स कसा आला.
Yes, ma'am.
Okay, rule number 13. Yeah. Okay, so that is how I can write. So you can cross check. हे आपण जे केलं तेच सेम रिझल्ट येत आहेत का बघूयात आपण. सो इथे x1 y1 च्या व्हॅल्यू मध्ये तुमच्या ओरिजिनल व्हॅल्यू ठेवून द्या तुम्ही. ओरिजिनल व्हॅल्यू ए बी ची काय होती तुमची 5 5 10 5 होते. सो आय विल राईट हिअर 5 5 द कोऑर्डिनेट्स ऑफ ए, देन द कोऑर्डिनेट्स ऑफ बी दॅट इज 10, 5 आणि 1, आणि तुमचं हा मॅट्रिक्स लिहिले मी 1 0 0 0 1 0 and tx ty ची व्हॅल्यू काय, tx 10 आणि ty पण 10. सो tx ची व्हॅल्यू 10, ty ची पण व्हॅल्यू 10 आणि 1. जर हे निगेटिव्ह डायरेक्शन मध्ये असते तर तुम्हाला -10 लिहावं लागलं असतं. कीप इन युअर माइंड. जर मी म्हटलं असतं की आय वॉन्ट टू शिफ्ट द लाईन टुवर्ड्स लेफ्ट, जर लेफ्ट साइडला ती लाईन शिफ्ट करायची असेल तर यू हॅव टू राईट -10 हिअर, कारण तेव्हा ट्रान्सलेशन फॅक्टर झाला असता -10 टुवर्ड्स निगेटिव्ह साइड. अँड डाऊनवर्ड्स म्हटलं असतं तरी सुद्धा y निगेटिव्ह झाला असता, बिकॉज यू आर रिड्युसिंग युअर y व्हॅल्यू. खाली शिफ्ट करताय म्हणजे काय, यू आर रिड्युसिंग y. सो यू हॅव टू थिंक ओव्हर while writing this tx and ty values, whether they are shifted towards positive direction or whether they are shifted towards negative direction. Okay, so that you have to consider. Okay, so that is about this p and p into t. So now after multiplication, what is the result you are going to get? 5 into 1, 5 plus 0 plus 10. So you are going to get 15. 5 plus 10. 5 into 1, that is 5. Then 0. And here 10 into 1, that is 10. 5 plus 10 is 15. Then first row, second column. So first row 5 into 0, 0. 5 into 1 is 1. And 1 into 10 is 10. So here you are going to get 15. Then the last, the first row and the last column. So 5 into 0, 5 into 0, and 1 into 1. So this gives you 1. Similarly, I will multiply this second row with first column, second column, third column, and I will get 10 into 1, that is 10 plus 0 plus 10. So I will get here 20. Then 10 into 0, 0. 5 into 1, 5 plus 10, that is 15. And the last row and last column is giving you result as 1. So ultimately, same coordinates मिळाले का तुम्हाला, 15, 15 आणि 20, 15. 20, 15. म्हणजे मी काय करतेय, जे मला ऍडिशननी मिळत होतं सेम रिझल्ट्स आय एम गेटिंग विथ दिस मॅट्रिक्स मल्टिप्लिकेशन. मग मिळालेला मॅट्रिक्स कायम लक्षात ठेवा, ट्रान्सलेशन मॅट्रिक्स हा पहिला आयडेंटिटी मॅट्रिक्स असतो, ज्याच्यामध्ये tx आणि ty हे एक्स्ट्रा एलिमेंट्स असतात. ओके, हा बघा तुम्ही, हा तुमचा आयडेंटिटी मॅट्रिक्स आहे. And here you have to write tx, ty, and here 0, 0, 1. So you have to remember this T matrix. And this is applicable for any problem. Getting it?
Yes, ma'am.
Okay. So the same line, let us move it to 10 to 15 units left and 15 units down. 15 units. This is your line AB. Same line AB you have to move 15 units left and 15 units down. So can you tell me what will be your T matrix in that case? Can you tell me? You have to move it 15 units towards left and 15 units towards down. Can you tell me Tx and Ty values? Yes.
Minus 15, minus 15.
Right. So here Tx and Ty both will be minus 15, minus 15. So this 10, I'm going to change. I will be getting minus 15, minus 15, because you have to shift the object down, that is minus 15 along y-axis. So Ty is minus 15 and left is also minus 15 along x-axis. Okay. So perform the multiplication and tell me the result. After multiplication, 5 into 1, 5, 0, minus 15. So 5 minus 15, it will give you minus 10. Similarly, first row, second column, 5 into 0, 5 into 1, that is 5 minus 15. So it is minus 10. And this row and last column gives you 1. Similarly, the second column will give you minus 5, that is 10 minus 15, then 5 minus 15. So it is minus 10. And 1. So these are the new coordinates after shifting the line 15 units down, 15 units left. मग आपण तो ती line draw करून बघूयात. So towards negative side it should be, right? कारण त्याचे coordinates आहेत minus 10, minus 10. So this is your minus 5, minus 10. This is your minus 5, minus 10. Okay. So minus 10, minus 10. म्हणजे तो point आहे इथे कुठेतरी. Minus 10, minus 10. That is your new A dash now. And minus 5, minus 10. So minus 5 is this x value and minus 10 is this y value. So this is your new line A dash, B dash. B dash coordinate at minus 5 and minus 10. So shifting of this line to a new location. Okay. Getting it? So I am shifting this line in the negative direction. All of you are getting?
Yes, ma'am.
Okay, so you have to remember this T matrix. Do not forget the T matrix is 1 0 0 0 1 0 Tx Ty 1. Okay, so let us move towards the slides. Okay, so the translation is over. Right. So here you can see that the matrix is performing the actually the addition, and we are going to convert it into multiplication. So earlier the addition is getting converted into multiplication, and that's why we are adding here one row extra and one column as well. So 2 by 2 matrix, which was there, that has converted into a 3 by 3 matrix. Okay. So you can solve this problem, that translate a triangle with coordinates 10, 10, 20, 10, 15, 20 by 3 units right and 5 units up. So can anyone draw the, or write, tell me the matrix? We will not go for multiplication, but just tell me only the P matrix, P and T. Yes. What is P matrix? It is your original coordinates A, B, and C. So A is 10, 10, and 1 is the extra element we are adding. Then 20, 10, and then comes 15, 20. So this is your P into T matrix. T matrix we already know, it is 1, 0, 0, 0, 1, 0, and Tx, Ty, 1. So now tell me the Tx, Ty values.
3 and 5, ma'am.
Right. So 3 units right means positive direction. So Tx is 3. And 5 units up means towards positive y-axis. So Ty value is 5. So that's it. So you have to perform the multiplication and get the result. That will be your new value, P dash. Okay. So you are going to get the result. So earlier triangle and next triangle that we will plot. So here is the 5, 10, 20, 30. Here 10, 20, and 30. Okay. So first was 10, 10. So this is your A point. Then 20, 10. So 20 and 10 is the second point. And 15, 20. So in between this and here somewhere. So this is your triangle ABC, original triangle. Okay. This is your point A, 10, 10, point B, 20, 10, and point C, 15, 20. And after shifting it, 10 plus 3, so I will have 13, 10 plus 5, I will have 15, 13, 15, so here I will be getting the result as 13, 15, 1. Then I will get here 20 into this, that is 23, 15, 1, and 15 plus 3, that is 18, 25, 1. So this is the resultant matrix I am going to get. So after plotting this, somewhere here 10 plus, this is your 15, which is at the C point, and 13, 15. So this is your 15 along y-axis. So I will change the color. Okay. So 13 is somewhere here, 15 is here. Okay. So this is your A dash now. Then 23, 15. So 20 plus 3 and 15 is here. 23, 15 and 18, 25. 18 means somewhere here. 18 and 25 is here. So this is your new triangle A dash, B dash, C dash. Here we are not changing the dimensions of the triangle. Okay, you can take the note of it. Size and dimension of the triangle आपण change करत नाही आहोत. आपण काय करतोय? Shift, simply picking the triangle up and moving to a new location. We are picking the object and keeping it in a new place. Getting this now, all of you?
Yes, ma'am.
Okay. Boys side, all of you are getting?
Yes, ma'am.
Okay. So that is about translation. Now the second, okay. Time is up. So we will stop here. And the rotation and reflection we will see in the next lecture. Okay. Give me attendance. Roll number 1,
Present, ma'am.
2, roll number 2 is not there. Roll number 3, roll number 3 is there. 4,
Present, ma'am.
5,
Present, ma'am.
6,
Present, ma'am.
7, 8,
Present, ma'am.
9,
Present.
10,
Present, ma'am.
11,
Present, ma'am.
12,
Present, ma'am.
13, 14, 15, 'Who has not given me the attendance? 13 ka? Okay. Okay, so we will stop for today. Thank you.